Hey folks, today we're talking about multiplying functions using graphs. Um, it's kind of tricky before you get it, but once you see it, it's actually, I think, kind of interesting, kind of fun. All right, so our first instructions are we're supposed to graph these three functions. So I would start plugging in a chugging. I told you which x values I want you to use, and you're going to figure out what f of x values you're going to get out. So when I plug -5 into this, that's -10. -10 plus 6 is -4. -4 plugged in would be -8 plus 6 would be -2. -3 plugged in is -6 plus 6 is 0. Now, when you're graphing a linear function, you can usually figure out the pattern pretty quick and you don't have to keep plugging everything else in. Now, this only works if you've got a linear function, and this is linear because it's x to the first. There's no roots, there's no x's on the bottom or anything weird. So you could keep plugging and chugging, or you could follow the pattern. Obviously, this is going up by 2. So my next one would be 2. Let's just double check that. -2 times 2 is -4. -4 plus 6 is 2. So I can just complete the rest of my table based on the pattern. Now I want to graph these points. So -5 is -4. 1, 2, 3, -4. -4 is -2. And then we've got a rise of 2 and a run of 1. So I'm just going to go ahead and sketch the rest based on rise over run. Grab my straight edge. All right, let's do it again. So now we're talking about the function g. G is equal to the equation x minus 1. I would not use a calculator for this. I would just quickly plug and chug. -5 minus 1 is -6. -4 minus 1 is -5. -5. -3 minus 1 is -4. And we see the pattern from here. -3, -2, -1, 0, and 1. Now I'm going to sketch this. -5 is at -6. 1, 2, 3, 4, 5. -6. -4 is at -1, 2, 3, 4, 5. 3 is at -4. And then I'm going to use the pattern of linear functions and rise over run to sketch the rest. Grab my straight edge. All right, I'm going to let you graph the quadratic on your own since I did the first two. So in a minute, I'm going to encourage you to pause, but I want to show you one trick on your calculator because I assume you'll need a calculator to fill out this table. So I would input -5 in for x. Remember that you're going to put parentheses around that. So 2 parentheses, -5 to the second, plus 4 times -5, subtract 6. That gives me a value of 24. Now, a lot of kids want to hit clear at this point because that's what you used to do with the old calcs. A much better thing to do is hit second and enter. I hit the second key and the enter button at the bottom here, and that brings up what you typed in before. And now I can go back and change these -5s to -4s, hit enter again, and we would get 10. So I'm going to encourage you to pause here. I obviously will never know if you do it, but this is the one I did the first two. Why don't you try to do the next one? All right, well, hopefully you filled it in on your own. These are the y values that you should have gotten. And now I can take those y values and I can try to graph them. So -524 obviously won't fit. So we'll go to the next one. -4 is at 10. -3 is at 0. -2 is at -6. -1 is at -8. And then because of our symmetry, because we have an even function when it's quadratic, I can just graph those other ones based off of the left side of the axis of symmetry. Now I'm going to play connect the dots and make this into our quadratic family. Ooh, that one was pretty good. Let's see how this one goes. I like that one better. Anyway, it's pretty good. It's a pretty good parabola. Okay, now we've got everything graphed. Identify the value of x such that f of x equals 0. Let's talk about notation here. We're going to talk about the difference between what is f of x equals 0 saying and what is f of 0 saying. So I'm going to go up here into the top part. I'm going to write a little note. So this notation, which we call function notation, invented by my favorite mathematician, Leonhard Euler. There's two things. When I write this down, automatically it's telling me three things. It's telling me the name of the function, number one. It's also telling me what the x value is. X would be 2. And it's telling me the y value. So in this succinct, real quick, small statement, I can know which function we're talking about. I know that we're talking about this function. I know that when x is 2, I guess I should have probably used 10 here. That would have made more sense considering. Anyway, maybe I should call this a different, whatever, you get the idea. This is telling me what x is. This is telling me what y is. This is telling me the name of the function. So if we have a statement like we have here, f of x equals 0, what do we know? What do we want? Do we know what x is? No, we do not know what x is. So x is the unknown thing here. Do we know what y is? Yes. And this is sort of takes you a little bit of understanding, but once you get it, it's pretty easy. This means this whole f of x is really one thing. It's not f times x, it's f of x. And this whole thing is equal to the y value. So when I say f of x equals 0, that's essentially saying this is a question. It doesn't look like a question, but this is a question. This is saying for the f function, what is my x value when my y value is 0? So we can now actually start to answer this. As I look at my picture, this is saying for the f function, what is my x value when y is 0? So there's two ways to do this. I can do this from the table. I can find the y value of 0 in the table and look at the x value. Or I can look at my picture of my graph and figure out where that y value, which point has a height of 0. Well, that's when x equals 0. So we would take this and we would write it not just what x is, we rewrite the whole statement. F of negative 3 equals 0. Now we're going to do the same thing, but we're going to do it for the g function. So in the g function, this is asking you, what is x for the g function? Let me try that again. What is x when the g function is at a height of 0? So I look at my graph, my yellow graph, my g function is at a height of 0 when x equals 1, and that translates over here to my table. That's the same thing that we found over here. So I would say g of 1 is equal to 0. Now, what do we call these values? That might not be something that you remember. We call these values, there's lots of different names for these because they're very important values. The one you're probably the most used to, what do we call these places where a line hits on the x-axis? We call these x-intercepts. Now, the other words that you might see are roots. You might see the word solutions. And then the most important one, the one that we're going to use the most in this class, and we've already done it, we've already talked about it, is zeros. We call these zeros. I'm actually going to underline zeros because from here on out, that's the one that you're going to see the most. Let's do that in orange. Zeros. X-intercepts, roots, solutions, zeros. Depending on who your teacher is, they might use different phrasing. All right, now let's talk about this notation, f of 0. So I'm going to go back up here. I want to write a little note about how this works. So this time it says f of 0. This is a question, believe it or not. It's a question and it actually gives us some information. In this case, f of x became f of 0. So what do we know? We know that x is 0. What don't we know? We don't know what the y value is. So that's what it's asking. Identify the value f of 0. That's saying what is the y value when for the f function when x is 0. So I'd go to my f function. I would go to x is 0. I would track up and see what height it's at. It's at a height of 6. Or I could go to my table, go to an x value of 0, and track over to the height of 6. So f of 0 equals 6. We're going to do the same. Actually, I'm going to pause here, let you try to figure this. What is g of 0? Okay, hopefully you figured out what this is asking. This is asking you for the g function. What height is the g function when the x is 0? So I go to when x is 0, I'm at a height of -1, or I could use my table. At 0, I'm at a height of -1. So g of 0 equals -1. What do we call these? These are values that you should know. You should already know the name for these. They only have one name, nothing special. What do we call these? We call these y-intercepts. Y-intercepts. Sometimes you might hear them called initial values, but that's pretty rare. Okay, let's have you figure out this one on your own. 3A, you have 10 seconds, go. All right, let's see how you did. Identify the values of x such that h of x equals 0. So that's asking me to figure out what x values for h are at a height of 0. So I go to my pink graph this time, the h function, and there are 2 times that this function is at a height of 0. Or I could look at my table, and there are 2 values that are at a height of 0. So our answers would be h of -3 equals 0, and then h of 1 equals 0. Explain why these zeros are the same as the zeros in 1a. Whoa, wait a minute. In 1a and 1b, I got that f of -3 was 0, and we got that same for h. And then g of 1 was, and we got that the same for h. G and h shared a 0, f and h shared a 0. Why would this be? Well, there's a hint here. Find the product of the functions f and g. So let's do that first. So I'm going to take the f function, f of x. I'm going to multiply it by the g function, g of x. So f of x is 2x plus 6. G function is x minus 1. Go get them. Distribute that. You don't need me to help you here. Now, eventually you want to get to a spot, if you haven't paused yet, pause and try to distribute on your own. But eventually you want to get to a spot where you can distribute this all in your head. So what I mean by that is I would say 2x times x is 2x squared. And then I know that the next two are going to be like terms. Because when I go 2x times -1, that's -2x. And then this is plus 6x. Those are like terms. So do that part in your head. -2x plus 6x is plus 4x. And then 6 times -1 is -6. What do you notice? OMG. This equals what function? That's my h of x function. So the big idea here, what we've hopefully made a connection on, well, maybe not, maybe it needs to be kind of explicitly explained. When I did this problem, I did it at Grand Valley in my master's program. And it was the first time I realized that parabolas are just 2 lines multiplied together. If I take my f function and I multiply it by my g function, and I start to look at the y values, let's go through and look at some of these y values here. When x is -4, this is at a height of, or f is at a height of -2, g is at a height of -5, and h is at a height of -10. What a coincidence. What's -2 times -5? Oh, sorry, positive 10. What? This point is at a height of 2. This point is at a height of -3. When I multiply them together, we get this point, which is at a height of -6. Parabolas are just 2 lines multiplied together. And a cubic would be 3 lines multiplied together. Or you could take a parabola and a line and multiply them together, and you get an x cubed graph. So anyway, you get the idea. I'm going to go on and on and on. But so a parabola is really just 2 lines multiplied together. So why are the zeros the same? Well, think about it. Think about it in terms of what these y values are. What is the y value here? Let me see. I'll use a blue. What is the y value here? 0. So when I multiply that y value of 0, I'm talking about for the f function. I don't care what my other function height is, because what's 0 times anything? It will always end up back at 0. What about this y value? This y value has a y value of 0. When I multiply it by any other value, I don't care what I get, I'll still get a 0. So the point is, the reason we break down a quadratic, why do we factor when we try to find zeros? Because it's really easy to find the zeros of these functions, just like we did right here. How did we find the zeros? We either looked at the graph, we could either set it equal to 0 and solve, or we could look at the table. But those zeros, the zeros of the factors, are going to be the same zeros of my overall function. That's why we factor. This is really hard to find the zeros of. But these two are really easy to find the zeros of. What would you do? If I set this equal to 0, what's 0 take away 6? -3, -6. Divide by 2 is -3. Look what happens when I set this equal to 0 and solve it. I would add 1 to both sides. I would get x equals 1. There's my other 0. Now, we couldn't have known that about this function. That's too hard to figure out. So what we do is we factor it, break it down into the lines that multiply together to make the parabola, and then we, what's called ZPP, we solve those individually, and we can find the zeros. So why are the zeros the same? Because 0 times anything equals what? Equals 0. All right, so what our goal is, what we're eventually going to do is we're going to want to take two graphs and we're going to try to sketch what the product of these two functions looks like. That's what our goal is. So let's go ahead and try to break down what happened up here, because we already know that the pink graph is the product of the purple graph and the yellow graph. So it says draw vertical lines at the values of x found in 1a, 1b, and 3a. So my values of x are 3, -3, and +1. -3 and +1. So now I'm going to draw vertical lines at -3 and +1. Okay, now, using the fact that h is the product of f and g, discuss why h have positive y values before the first vertical line. Negative, blah, blah. I'm going to stop there and try to break down what this is saying. Using the fact that h is the product of f and g, discuss why h has positive y values before the first vertical line. H is the pink function. Maybe we should label these. This is my h function. This is f. And this is g. What we're trying to figure out, why does it make sense, since we already know that f times g is the graph of h, why does it make sense that the y values for h are positive before this is 0? Well, let's look. What are the y values of f in here? They're negative. What are the y values of g in here? They're negative. And what do you know when you take a negative and you multiply it by a negative, you get a positive. So that's how I knew that these y values would be positive, because a negative times a negative is a positive. Let's look at the next section in between the next zeros. What are these y values? These are positive y values. What are these y values? These are negative y values. So if I take a positive and I multiply it by a negative, I'll get a negative. And what are all these y values in here? These y values are negative. And as we move to the last section, it kind of you're probably getting the idea. These y values are positive. These y values are positive. A positive times a positive is a positive. So these y values would be positive. So let's try to kind of organize that in a little statement here. We'll say, okay, why does h have positive y values before the first vertical line? H has positive y values for all, this is our symbol for all. I'm going to write a little note on the bottom there. Upside down, I'll do it. I never like to use black. It always looks like it's part of the, I want it to stand out. It always looks like it's part of the notes. This symbol means for all. X has positive y values for all, H has positive y values for all x that are less than -3, right? Up here, all the y values that are smaller than -3, H has positive y values. Why? Because F and G have negative ones. H has positive y values for all x that are less than -3 because F and G are negative for all x less than -3. Okay, sticking with that idea. Why does H have negative y values between the vertical lines? Why are these values negative? Because H is positive, or F is positive, and G is negative. So let's write that up. H has negative y values for all, and then when you want to write an interval where the x's are between two numbers, you start with the smaller number. -3 is less than x, so that covers everything smaller. Sorry, let me try again. That shows that x is on the greater than side of all the numbers in -3, but it's on the less than side of 1. So that means all the x's are smaller than 1, but at the same time, they're bigger than -3. H has negative y values for all x's between -3 and 1 because F is, okay, let's go back up to our picture. What do we know about F? F is positive in here. F is positive, and G is, let's go back up here, G is, my G functions are all negative. For all x between -3 and 1. And then the last question, why are the H values positive after the second vertical line? That's because the F values and the G values are both positive as well. So H has, why don't you try to write it up? Pause here and try to write it up. H has positive y values for all x's that are greater than 1 because F and G are positive for all x greater than 1. Okay, so hopefully we've got the idea of how this works sorted out. Now let's actually put it into practice. So this is going to be the same picture, but let's pretend like we didn't already know that the graph what it looks like of H. Let's pretend like we don't know that H is going to be a parabola, and we basically already know what it looks like. So we're going to take the F function, we're going to take the G function, and we're going to try to make H out of them. So how do we do this? This is my advice. You don't have to follow it exactly, but this is what I found to be the most effective. Number one, identify all zeros. That means anywhere there's a zero on of the other graphs, we want to highlight those because those are going to be zeros for my new function, the product of these two graphs. So I would highlight this as a 0 and that as a 0. Number 2, sketch boundary lines Okay, what do I mean by boundary lines? Boundary lines are vertical lines at all zeros. So there's a 0 here. I would draw a vertical line. What that means is everything is going to separate this into a section, everything before this 0. Draw another vertical line at the other 0, everything between the zeros, and then everything after this 0. And then last but not least, we would compare number 3, compare the function values I'm going to move that. Compare the function values. Now the function values are either going to be positive or negative because we've highlighted all the places where that's a 0. Compare the function values, positive or negative, between the zeros or around the zeros. I don't know if between is the best way to say it, but so what does that look like? So that means in this section, what are my y values? My y values are negative and negative. What's a negative times a negative? That means in this section, our graph should be positive. What are my y values? Negative, try again, positive and negative. What's a positive times a negative? That would still be negative. And then in this section, I have positives. So a positive times a positive is positive. All right, let's make our sketch. Now, you have to hit the zeros. So the first thing I'm going to do when I'm sketching this is make sure that I'm going through my 0 values. In this section, what are all my function values going to be? They're going to be positive. In this section, all my function values are going to be negative. In this section, they're going to be positive. So this section has to go positive. Now, this section is going to be negative, but I'm going to have to turn back at some point and head back up to this 0. So a lot of kids ask, how far down am I supposed to go? It doesn't matter. You can pick whatever number you go down to. I'm not going to be that picky. I'm just looking for a general picture. I'm just looking that this h function is going to look basically like it's supposed to. So as I compare, here's the h function I drew over here. This is the h function we found by actually plugging in points. Like you'll notice I didn't hit this value. I also didn't go down far enough. That's okay. That's okay. This would be full credit because it has the same general picture as the h function that we found by plug and chug. Okay, so I'm going to have you pause here. Try to figure out what is the product of P and Q. What would the graph product be of these two? Okay, let's see how you did. If you haven't paused yet, I really encourage it. So I'm going to first highlight all my zeros because the zeros are going to stay as zeros. 0 times anything is 0. So anytime I cross the x-axis, I'm still going to cross the x-axis at that spot. Then I want to identify the sections. So I'm going to put a vertical line. You don't have to do this, but I like it because it helps me organize that there's how many sections that I'm going to have to break up. Now I want to analyze the function values. So I would go through and I would put a little indicator of what the y values are. In this section, these y values are negative, these y values are negative, so these overall y values are going to be positive. In this section, these y values are positive, these y values are negative, so in this section, I'm going to have a negative. These are positive, these are negative. When I multiply a positive and a negative, I messed that up. It would be a negative. Then these are positive. These are positive. A positive times a positive is still positive. So it's time to finally make our sketch. I want to hit these zeros, so I'm going to highlight them again. All right, this section is positive, so I'm going to have it going uphill in here. Now, this is all negative. These are all negative, so some kids will just go negative. No, you've got to hit all zeros. So as I go negative into this section, I'm going to have to curl back up so that I can hit this spot. And it actually doesn't, you want to curl up what we call smoothly. So you don't want to come in like an absolute value with a sharp turn. Then this section is negative again, but I have to curl up until I hit there. Now from here, bada boom, bada bing. This is the function. I always like to label it at the end. This is the function P times Q. We didn't name it as a new function. We just called it the product of P times Q. Okay, hope that made sense. You got a couple to do on the homework assignment. And yeah, that's it. All right, good luck.